Hi, hello everyone. So we're just doing a quick coordinate geometry revision. So this is, I think, from a 2019 mock, if I am correct. So it's not too taxing of a one. It's an interesting one, and you'll see that in a second. There's some interesting little bits in it, but in generally speaking, it's not the hardest one you'll ever come across. So we have a line 3x minus 4y plus 6. It intersects the x-axis at A and the y-axis at B. Find an equation for the perpendicular bisector of AB. Okay, so that means we need to find, first of all, we need to find coordinates. That'd be handy, of A and B. So let's find the coordinates of A. So the coordinates of A is where it cuts the x-axis. And it cuts the x-axis at y equal to 0. So that'd be 3x plus 6 equal to 0. Take away 6 from both sides. 3x equal to negative 6, x equal to negative 2. So the point A is minus 2 and 0. Now the point B, let x equal to 0, because we're finding the y-interceptor. So we've got minus 4y plus 6 equal to 0. Take away 6 from both sides. Minus 4y is equal to minus 6, and that means y is equal to 3 over 2. So the point B is 0 and 3 over 2. So now we have the point A and B. We're going to the perpendicular bisector. Find the equation of the perpendicular bisector. So to find the equation of anything, you're going to need a slope and you're going to need a point. That's all you need. Okay. So first and foremost, we'll find the slope of AB. Okay. So that's that bit. Find the slope of AB, invert it to get the perpendicular slope, and then get the midpoint of AB, and then you have a point and the slope. So there is a bit of work here to be done. So let's find the midpoint, I suppose, first of all. It's an easier one. So the midpoint of AB, so you have minus 2 and 0, and 0, and 3 over 2. And the midpoint, just add the x's divided by 2, add the y's divided by 2. Okay, so add the x's divided by 2, that's minus 2 divided by 2 is minus 1. Add the y's divided by 2, so that's 3 over 2, so that's 1.5 divided by 2, which is 3/4. So there's the midpoint. There's the midpoint. Now I need the slope. Same thing again. Same points. Let's go x1, y1, x2, y2. So we're going to get slopes. That's y2 minus y1 over x2 minus x1. So the slope is going to be 3/4. So if the slope is 3/4, that's the slope of AB, but we don't want the slope of AB. We want the slope of its perpendicular. So the actual slope we want is minus 4 over 3. Turn it upside down, change the sign. We've done that before plenty of times. So let's do our formula. We have a point, and we have a slope, x1, y1. Y minus y1 is equal to m on x minus x1. So let's see, multiply everything. I'm trying to think why we can multiply everything by something nice and easy. 12, I suppose. I'm just saying you can multiply it by 3, but then you've got the 4. So the lowest common multiple of 3 and 4 is 12. So listen, we'll go for it and see what happens anyway. You can always knock it down a little bit. So multiply everything, or will I? You know what? I'll multiply this side by 3, and then we'll see. So that's 3y minus 9 over 4 is equal to minus 4x minus 4. So bring them all together. You've got 4x plus 3y, and what have we got here? Minus 2 1/4 plus 4. 7 over 4, 1 3/4. Now you can multiply that by 4 again to get that out, but that's grand. It's not going to kill anyone the way it is. Right, so That's a nice one. There's a little bit of everything there. There's nothing there beyond the kind of junior cert honors if you really kind of think of it. So let's move on to the kind of main show here. The equations of the diagonals of these parallels. Sorry, the equation of the diagonals of a parallelogram are this and this. The line contains one side of the parallelogram. Find the area of the parallelogram. Ooh, okay. So let's try and think now. There's a couple of things we could go here. I'm trying to think. A parallelogram. If you get the area of one of the triangles in the parallelogram, multiply it by 4, you'll get the area of the parallelogram. That's 1. So if I could get 3 vertices, 3 corners, I'd be good to go. I can definitely get this one from the intersection of those two, that one from the intersection with that, and that one from the intersection with that. So I could go down that route. So we're really kind of doing a hell of a lot of, I think, is there another cheaper way? I mean, the other way on is based by external perpendicular height, but don't really have anything to go with on that one. Okay, I'll go this route. So let's get this fella here anyway. So that the middle vertex, that's just going to be x minus y equal to 7 and x plus y equal to 1. That's 2x is equal to 8, x is equal to 4. So if x is equal to 4, y is equal to minus 3. 4 and y is equal to minus 3. So this one in here is 4 and minus 3. So that's one of the points. Okay. Now, this line contains one side of the parallelogram. So we're going to get an intersection point with that and with that. Now, I don't know which one is which. It doesn't really matter. So we're just going to, again, simultaneous with one of them. Doesn't make a difference. So let's simultaneous it again. X minus 5y equal to 7. And x minus y is equal to 7. So let's cancel the x's. That's negative. That's positive. That's negative. So y is equal to 0. Y is equal to 0. And that means x is equal to 7. So 7, 0 is one of them. I don't know which one it is, but let's just put a 7, 0. It doesn't make a difference. Okay? So we'll do it again. We have x minus 5y equal to 7. And we have x plus y equal to 1. Okay, change the signs. 6 is equal to 6y, y is equal to 1. Is that, no, y is equal to minus 1. Y is equal to minus 1. Okay, so if y is equal to minus 1, then x is equal to 2. So it's 2 and minus 1. 2 and minus 1. So now I have 3 vertices of my triangle. Okay, so I have 7 and 0, 2 and minus 1, and 4 and minus 3. But, and you know, this is where this is common. We have to only use 2 of them because this is our formula. Remember, for the area of a triangle using 2 vertices. So we need one of them to map onto 0. So let's just map this to 0. So that goes to 0 by taking away 7 and doing nothing. Okay, so take away 7, do nothing. Take away 7, do nothing. Okay, so here we have our x1, y1, x2, y2. So I have the absolute value of x1 by y2 by y2, x1 by y2, minus x2 by y1. So I clear out for this one. That's 6. So one of those triangles is 6 times 4 equals 24 square units. Okay, there you go. Nice and done. Right. Now on to our friend the circle. Right, so this one's a bit more And again, these look traditional, even though it's only 2019, so it's only like 2 years ago. They still look very traditional. Find your center and radius find the center and radius of this. Okay, so if it's in this general form, just general equation form, the center is going to be negative g, negative f, but that's 2g and 2f. So you basically just half that number and change the sign. So half of 2 is 1, so that's a minus 1. Half that number and change the sign. Half of negative 4 is negative 2, change the sign, you got 2. So there's the center. And the equation for the radius is always going to be the square root. That's in your log table. It's g squared plus f squared minus c. So that's going to be square root of 1 squared plus minus 2 squared minus 20, which is 5. And that's the radius. Cool. That's a nice little one just to kind of get you going on this one. Now, two lines L and K intercept at the point 2 minus 2. And the distance from the center of the circle C above 2L and K is this. Ooh. So I'm just going to cover the rest of that because we need a bit more space on this one. So two lines L and K intersect at a point 2 and minus 2. The distance from the center of the circle C to L and K is 2 root 5. Find the equations of L and K. So to me, you're kind of visually, I think you're probably talking about, some type of, let me try and think of this now. I don't know, you could be talking about some type of situation, and there's your center, that type of way. So you could be talking about that, okay? But listen, I'm not sure. Unless you draw it, you're not going to be sure, but we're not going to draw it anyway. So let's try and just work it out just from the logic of this, okay? So slopes, okay? For slopes, you're going to need points for equations, you're going to need points and slopes. So let's try and figure out what we have for sure, okay? We do have the center of this original circle, and we do have the distance from the center to this point, okay? From the center of the circle to is that, okay? So we do have, to me, that's something like perpendicular distance type of situation. So let's put in what we know, okay? So let's pick one of them. Let's pick L, okay? So it's the formation of L is as follows. Y minus y1 is equal to m on x minus x1. Now, we're going to need some information, okay, about this. Okay, so we have 2 and minus 2 is definitely a point on it. So 2 and minus 2 is definitely a point on this, okay, which means I can use it to build the equation. So that's x1, y1. Y minus y1, there's a double negative, is equal to m on x minus x1, okay? So that's y plus 2 is equal to mx minus 2m. So bring it all together. mx minus y minus 2m minus 2 equal to 0. Okay? So you can probably factorize out there if you really want to. Okay? So this bit here is that this whole bit will be the constant. There's your coefficient of x, there's your coefficient of y. I'm just trying to build this ahead now into our perpendicular distance formula. So our perpendicular distance formula is, if I remember correctly, it's ax1 plus by1 plus c over the square root of a squared plus b squared, and it's an absolute value. Okay, so let's try and think here now. So we have the distance from the center of the circle to it is 2 root 5. Okay, so let's make 2 root 5 equal to that. And we have the external point. So we have all the information we need. We have our equation. We have m x minus y minus 2m minus 2 and we have an external point, which is going to be 1 minus 1 and 2, and we have a distance, which is 2 root 5. So let's put it all together. 2 root 5 is equal to the absolute value. So a times x1, that's m times minus 1, plus b times y1, plus minus 1 times 2, plus c, in a bracket, what have we got here? Minus 2m minus 2. All over the square root of a squared plus b squared. That's m squared plus 1 squared, which is just 1. Okay, so that's everything now. Let's do some magic on this. We can cross multiply this. Sorry, I needed extra paper here. So hope everyone with me so far on this. So we've derived a general equation for L, just using the point we know is on L. We've got a perpendicular distance equation. We're going to use this general equation with the external point, which is the center of the circle, and distance that we've been told, okay, from the center of the circle to this, okay? And we're going to see, can we work this out? Let's have a look. Multiply this both sides by the bottom. So we're going to get, let's move this up a little bit. So we're going to get 2 root 5 times the square root of m squared plus 1 equal to, right, let's tidy this up, minus m minus 2 minus 2m, so that's minus 3m, and another minus 2, so that's minus 3m minus 4. Okay, so far so good. Square both sides. It's the only way we're going to get around this. So if I square this side, I'm going to square this side. Squaring this side, I'm going to get, what am I getting here? Let's see, square the left, 9m squared. Square the right, 16. Multiply them together, minus by 12, 24m. Square this side, ooh. Okay, square the left. Square the right. Right, square the left. That's 4 5. That's 20. 20 squared. And then square that. That's m squared. So 20m squared plus 20. 20m squared plus 20. Okay, so that's looking like a quadratic. Let's bring it all together. That's 11m squared. Bring that over. Minus 24m plus 4. I think, yeah. No, hopefully this has to fix. This has to work. 11m and m, 2 and a 2, and 2 minuses. So m is equal to 2, or m is equal to 2 over 11. So, so if we have 2 over 11 as a slope, we pop that in, and we get an answer. Okay. Did they give me any information here which one to use? Let's go back up to the question. 2 lines intersect, and that's no find relation to value now. Okay. Nice. So now that you have a slope, you can have, and you have a point. What have we got? 2 and minus 2. So I can have y plus 2 is equal to 2 over 11 on x minus 2. And that's going to be 11y plus 22 is equal to 2x minus 4. That's 2x minus 11y minus 26 equal to 0. Okay, let's do the other one, just for the fun of it. If m is equal to 2, with a 2 and a minus 2, okay, y plus 2 is equal to 2 on x minus 2. Y plus 2 is equal to 2x minus 4. That's 2x minus y minus 6 equal to 0. So there you have your 2. Okay, so we don't know which one is which, we don't care, but there they are. That's an epic. Okay, it's a little bit of an epic. Right, last bit of the question. Right, there we go, look at this one. Right, show that the measure of the angle between the two of them is is theta. Show that the sine of theta is 4/5, so you need to get the measure of the angle between them, basically. So what's the measure of the angle? And that's our tan formula, isn't it? Tan theta is equal to plus or minus m1 minus m2 over 1 plus m1 times m2. We have our numbers. It's not going to be hard. So tan of theta is equal to plus or minus 2 minus, what is it, 2 over 11 over 1 plus 2 by 2 over 11. So 2 minus 2 over 11 divided by 1 plus 2 times 2 over 11. 4/3. So it's plus or minus 4 over 3 is the tan of theta. Okay. So let's have a go at this. If the sine of theta is 4/5, that means it's going to be less than 90 degrees. Okay, so we're really looking at tan of theta being 4/3. 4, 3, 5. That's a classic triangle. Okay, there's nothing too hard there. So that means the sine opposite over is equal to 4/5. QED. Done. Hope that helps you, lads. It's a nice little run through of everything.